Welcome to Maths for All. I'm Aisling Flynn. This is Complex Numbers 1.3, Complex Conjugate and Division. The complex conjugate. If a complex number z is 2 plus 3i, its complex conjugate z bar, z with a line on top of it, is 2 minus 3i. The sign of the imaginary part is changed, and that's the only part that changes. Okay? For example, if you had a different complex number, let's say z1 equals minus 3 minus 4i, its conjugate, complex conjugate with a hat on it, is minus 3, so the real part stays the same. The sign on the I part is the only bit that changes. If you had a number just with an imaginary part, so let's say 5i, its complex conjugate is minus 5i, and so on. Okay, so here's some examples. So z1 bar, okay, so the complex conjugate of z1, there's z1, z1 bar is 2 minus 3i, so only the sign of the I part changes. Now twice the conjugate of z2, so 2 times the conjugate of z2 is 3 plus 4i, so only the sign of the I part changes, and then you would multiply that out, you get 6 plus 8i. Now here we have to add z1, which is 2 plus 3i. We have to add to it the conjugate of z2, which is 3 plus 4i. Okay, and there we get the real parts are 2 plus 3, the imaginary parts are 3i plus 4i, so we get 5 plus 7i. And here we have some multiplication. Okay, so the conjugate of z1, which is 2 minus 3i, to be multiplied by the conjugate of z2, which is 3 plus 4i. Multiplying that out, we get 2 by 2. 2 by 3 is 6. By 4i is plus 8i. Using the minus 3i, we get minus 9i minus 12i squared. There's I squared, circle it. Okay, so we have 6. Now we have 8 minus 9i gives me minus 9, and because I squared is minus 1, it will change my minus 12 to plus 12. So for a finish, we have 6 and 12 make 18 minus I. Okay, now the fifth part is another multiplication. It has the conjugate of z1, which is 2 minus 3i, multiplied by regular z2, which is 3 minus 4i. So let's compare the answers here. 2 by 2, or using 2 first, 2 by 3 gives 6, and 2 by the 4i gives minus 8i, minus 9i, by plus 12i squared. Again, there's I squared identified immediately. It's going to be minus 1. And so we'll have 6. So minus 8 minus 9i give me total of minus 17i. And minus 1 by 12 gives me minus 12. So I have 6 minus 12 for the real part. That's minus 6 minus 17i. Okay, now dividing complex numbers. Now this is a special technique. You must recall that this is how you do it in an exam. There will be no hints or pointers towards it. Okay, so to divide complex numbers, we multiply. So we're using multiplication, the top and bottom of the fraction. So division looks like a fraction. Okay, we'll see that in a minute. For example, A over B means A divided by B. Okay, so we'll multiply the top and bottom of the fraction by the complex conjugate of the denominator. Okay, so remember the denominator is the part under the line. Okay, we'll multiply the top and the bottom by the complex conjugate over the complex conjugate. If you multiply a fraction by the same thing, top and bottom, you're not altering its value. So here's an example. Write in the form p plus qi, and p and q are real numbers, okay, this. So first thing, it will be presented like this. The word division may not be mentioned, so you have to recognize it as division. 1 plus 3i is to be divided by 1 plus I. Okay, the next thing you must remember is the technique to multiply the top and bottom by the complex conjugate of the denominator, or the bottom. Okay, so here our denominator is 1 plus I, so its conjugate is 1 minus I. So we've taken the denominator and multiplied top and bottom by its complex conjugate. So it's a conjugate because the sign of the I part has changed. Okay, now we'll see why this works in a moment. It works to remove any i's from underneath the line, from underneath, and then it makes division possible. Okay, so multiplying out, so we multiply top by top, so it's 1 plus 3i by 1 minus I, so top by top. And that's the result that I get here. 1 minus I plus 3i minus 3i squared, and there I've put I squared in red. That's equal to minus 1, and it simplifies the top line here to 1 plus 2i plus 3. Okay, so take a moment there to look at that, pause it if you have to, and underneath the line we get this, and this is why we do this method. So how do we get underneath? We multiply bottom by bottom. Okay, so it's 1 plus I has been multiplied by 1 minus I, and this is what we get. And we do it because you always get two middle terms that are equal but opposite, and they cancel to give 0. Okay, so the I disappears. You do have an I squared, but we know that that's equal to minus 1, so minus minus 1 becomes plus 1 over here. Okay, so after all the tidying up, what do we get? We get on the top line, we get 4 plus 2i over 2. And now we can do division. We can say 4 divided by 2 equals 2, and 2i divided by 2 equals 1i. And that's my result. Okay, so rewind, look at that again, go through the process. Division, we multiply the top and bottom by the complex conjugate of the denominator, and it works because it eliminates any i's under the line, and then we can do division. Okay, so let's do an example to rehearse that one more time. Okay, so first you must recognize that this means division and that we have our special technique. Okay, we're going to multiply by the complex conjugate above and below. Okay, so writing down my division, I'm going to multiply it by the complex conjugate of the bottom of the denominator, so that's 2 plus 3i over 2 plus 3i. Okay, so the next thing we're going to do is we're going to multiply our fractions, so that means the top by the top. You can take as much space as you need to do this multiplication. Okay, so let's work with the 6 first. 6 times 2 is 12, 6 times 3i is 18i, and now I'm working with the plus 2i. 2i by 2 is 4i, and 2i by 3i is plus 6i squared. Okay, all over. Now let's look at the bottom line. Again, it's 2 by 2 multiplication. You can put brackets around them if it helps. Okay, 2 by 2 is 4, 2 by 3i is plus 6i. Now that was the 2. Now let's multiply by the minus 3i. We get minus 6i minus 9i squared. Okay, so let's tidy up here. Firstly, I'm going to identify my I squares as minus 1, And next, under the line, I see I have a 6i minus a 6i. So 6 takes 6 is 0, so they effectively disappear. And above the line, I can simplify by combining my i's here. So I have 12 plus 22i. Now, I squared is minus 1, makes that a minus 6. Okay, under the line I have a 4, and I squared is minus 1. It turns a minus 9 into a plus 9. Okay, now simplifying one more time, in real numbers on the top line I have 12 takes 6 is 6, plus 22i over 13. And to present the answer as was asked, so they want us to separate the real and the imaginary, I'm going to put 6 divided by 13 is the real part, plus 22 divided by 13 i's. Okay, and that's the finished result, presented in the form that was asked. Now it's time for you to try that. It will take a bit of practice. You have a quiz and you have a worksheet.